Let's go ahead and implement the abstract factory pattern for Dome Trains Quest. Now, what I'm going to do in this solution is not split it by concern. So over here we have the factories and the products, and the separation is per concern. Instead, I want it to be divided per level or per feature. So what I want us to do over here is to say that we have the cave level and the haunted house level, and we'll also have a common folder for the things that are common. Now, the common things are going to be the abstract factory. In our case, it's going to be the level element factory. So let's go ahead and paste this over here. And also the underlying game elements, which are the base products. So let's go ahead and move the base products over here as well. And now let's go ahead and delete the products folder and the factories folder, and let's fill in our specific example. So the abstract factory is now called the level element factory, and the underlying products are the enemy, the weapon, and finally the power up. Let's also update the return type to be enemy, weapon, and finally power up. Let's also, of course, fix the namespaces and the file name. And now all we have left to do is to create these three. What I'm actually going to do is to delete the two products. And then let's create here the enemy, which will simply be an interface called enemy. And alongside this, let's create also the weapon and rename this to weapon. And lastly, the power up, which likewise, let's update this to be power up. Now that we have this, then the abstract factory can compile successfully. And now all we need to do is to implement the concrete types for the two levels. So starting from the cave level, let's create over here the cave level element factory. And of course, this will be a class called cave level element factory. And this will implement the level element factory. And the three methods over here will be returning the goblin. For the power up, then we're going to have the crystal. And for the weapon, then we're going to have the axe. So let's go ahead and create the axe, the crystal, and the goblin. And let's move each one of these to its own file. And likewise, let's go to the haunted house and create here the haunted house level element factory. And of course, this will again extend the level element factory. And the implementation for this will be returning a new ghost. For the power up, then we have an orb. And for the weapon, then we have a staff. Same thing like before. Let's go ahead and create the staff, create the orb, and create the ghost, and move them to the corresponding files. So overall, what we have in the common folder, we have the things that are common for the entire game engine. This is the various underlying game elements or level elements, and the abstract factory, which is the level element factory. And alongside this, we have the two levels, the cave level with the axe, the crystal, and the goblin, and the haunted house level with the ghost, the orb, and the staff. Now that we have this, then back in the client code, we can go ahead and create the method that we looked at in the previous section, which is the setup environment method, which has simply the level element factory. And let's simply call this the level factory. And this over here can go ahead and create the enemy, the weapon, and the power up using the abstract factory, and then over here do whatever it wants. All we need to do now is to call the setup environment method with the two concrete level element factories, which are the cave level element factory and the haunted house level element factory. Now in our case, then we could have definitely had the abstract class simply be an interface. So over here, this is abstract, but this could have also just been an interface. And in our case, would make a bit more sense because there is no reason for the base of this entire thing to be an abstract class. But if we did have this in abstract class, then we can, similar to what we did in the factory method course, we can go ahead and add over here a method called setup environment. So we can have over here a public void setup environment that basically contains the code that we have in the client. So we can have this sitting over here. And of course, it doesn't need to access anything via the level factory because it is the implementing types. And we can have the logic contained over here. But of course, what you'll actually do is dependent on your specific solution. And of course, this isn't a right or wrong. You can do whatever works for you. Now that we looked at the actual implementation, let's go ahead and do a quick recap of this section. And then let's go ahead and talk about the benefits, the drawbacks, and finally conclude the course. So in this section, we went ahead and we implemented the abstract factory twice. We did it one time just modeling the pattern in code, where what we did is we created the abstract factory and the implementation of the abstract factory in the concrete factory. And then we went ahead and we created two products and the concrete products. We showed that what this does is it removes the direct dependency from the client on the concrete types, and instead the client can go ahead and just use the interfaces or the abstract classes. We then went ahead and implemented it on DomeTrain's quest, and over here we set up the folders a bit differently, where we created a folder per level. So we had a folder for the cave level and a folder for the haunted house level, and each one of them had the game elements and the factory corresponding to that level. And anything that is common and needed across both of these folders sits inside the common folder. We then looked at how the client can go ahead and use the factory to create the underlying game elements that are now part of the same family depending on the level. Now let's talk about the benefits of using this design pattern. Overall, we're going to talk about 3 benefits for this design pattern. Number 1 is separation of concerns. So looking at 3.1, then if we aren't following the pattern, then we have a direct dependency on the concrete products. Following this pattern, and this should be pretty obvious at this point of the course, where what we're doing is we're decoupling the instantiation and the logic involved in creating the objects to a different component. And in the client component, then we only care about the underlying behavior and the actions that we want to take. The next benefit that I want to talk about is flexibility. So following this design pattern, then you're very flexible to go ahead and switch between the family of objects that you're returning. You can very easily add another level and go ahead and return those objects instead, or update whatever you want. And from the client's perspective, then everything can stay the same. Last and most important, and this is probably the main motivation to follow this pattern, is that you know you're going to have consistency among the products. You don't need to fear as the client that these products won't be compatible with one another, because you're trusting that the factory creates objects that work together. Now let's go ahead and talk about the drawbacks of following this pattern. So looking at the drawbacks of following this pattern, then the most obvious thing, and this is similar to what we had in the factory method pattern, is that we're increasing the complexity. Of course, it's easier or it's less complex to go ahead and use the concrete products. What we're doing over here is we're introducing many abstract classes and many interfaces, and the client no longer interacts directly with them, but instead there's all this indirection, and this, of course, increases complexity. It's important when thinking whether or not to follow this design pattern to think if the added complexity which you're guaranteed to have when following this design pattern is worth the benefits of having the decoupling, the modularity, the ability to create more factories easily. The question is it worth the added complexity? If you're developing a game and you're going to have several levels, then of course it definitely makes sense to follow something like this. But if you go ahead and use this extensively, then you're going to be increasing the complexity by a lot. Again, like with the factory method pattern, the more classes you have, the more classes you need to maintain and test, and this may make the project harder to maintain. That said, many times this makes the project easier to maintain because of the separation of concern and the modularity. You need to weigh the pros and the cons and see that this makes sense for you. The last drawback that I want to talk about, and this is important, is that it may be tough to introduce new products. What we have over here is we have the product that may not necessarily always share the same set of methods and actions and properties that you're defining in the base class or interface. Creating the base class or interface can be hard, and it also couples or potentially couples all the various concrete products. In the example of the game, then it's not hard to imagine that if we have the power up, then the power up will behave completely differently in different scenarios and depending on the power up. And having this interface that is now manipulated by the client in a way that makes sense across all the various levels can be complex. And it may be hard to introduce new products over here or changing products. And in a way, we have here more of a coupling. So it's important when weighing whether or not to introduce this pattern to make sure that it's worth the added complexity, the added coupling, etc., because it may not always be worth it. And the complexity, as much as it adds it generally when onboarding to the project, etc., not all developers are familiar with this design pattern. And for those who aren't familiar with it, then of course, it can be even harder to understand what's happening. Now that we've covered both the benefits and the drawbacks, let's move on to the conclusion of the course. So in this course, we talked about everything from the definition to the class diagram to examples to implementing it in code. There was a lot in this short and condensed course, and I hope that you're able to see how powerful this design pattern can be, but also how it adds complexity that may not always be worth it. Where it is appropriate, then it can be extremely, extremely powerful and can make the life of the developers in the project much, much better. So that's it for this course. I hope you enjoyed it and you learned something new. Now what you should do is you should take a look at the list of design patterns here on Dome Train, choose the one that seems the most interesting to you, and I'll see you there.